Hello, it is Mrs. Scarpel, and in this video we are going to go over yet another method for solving quadratic equations, the quadratic formula. Keep in mind a quadratic equation is an equation written in the form ax squared plus bx plus c equal to 0. You must have the x squared term, so a cannot equal 0. So a is the coefficient of that quadratic term, the x squared term. B is the coefficient of the linear term, or the x term, and c is our constant. We will use those values, those coefficients and the constant, to replace the a, b, and c values in our quadratic formula. And what we end up solving for are the values of x that would make this equation true. We call those values roots. So we have opposite of b, and I like to say opposite of b rather than negative b, just in case your b value is a negative number, then you would have a positive number here. So the opposite of b plus or minus the square root of b squared minus 4 times a times c, or 4ac, and all of that, the negative b plus or minus the square root expression, all of that is in your numerator and divided by 2a. So let's take a look at using this. I have the formula up in the corner for us to refer to for setting it up. And I would recommend taking the time to identify your a value, your b value, and your c value. The a value, I don't see a coefficient in front of x squared. Remember, if you do not see a coefficient, that coefficient is 1. The b value is 5, and the c value, the constant, is 1. So now I have my a, my b, and my c, and I can replace the a, b, and c in the formula with these values. So we have x equals opposite of b, so negative 5, plus or minus the square root of 5 squared, and I'm writing this in parentheses because if b happens to be negative, you have to realize that you're going to be squaring a negative number. So I always write my b value in parentheses to make sure when I square it, I end up with the correct sign. Minus 4 times a, which is 1, times c, which is also 1, all over 2 times a, or 2 times 1. So we have x equals, at this point is just simplifying using our order of operations. We have negative 5 plus or minus the square root of 5 squared, that's 5 times 5 is 25. And then you can think of this as negative 4 times 1, which is negative 4, times 1 is still negative 4, so 25 minus 4, all over 2 times 1 is 2. Now we can simplify under that radical, so the negative 5 plus or minus the square root of 21 over 2. Now we could consider this to be the exact answer. I do want to show you that this answer can be written as negative 5 halves plus or minus the square root of 21 halves. When you're taking a standardized test, such as the SAT, you may see answer options in this conjugate form. If you're asked for the approximate answer, we would need to use our calculator, and we would need to find negative 5 plus the square root of 21 over 2, and its approximation, and the approximation of negative 5 minus the square root of 21 divided by 2. So these two forms that I have first, those are considered to be exact answers, exact roots. What I'm going to find now, using my calculator, is going to be the approximate answer. So in the calculator, if I enter my numerator inside parentheses, bring my calculator back here. So I want to enter this in parentheses, and we'll try this one more time. Calculator, here we go. Entering the numerator in parentheses, I can enter it all at once. And remember, for that negative on the 5, you want the negative button that's below the 3. So negative 5 plus the square root is that blue symbol right above the x squared button. Anything in blue, you want to press the blue second button, so second x squared, 21. And now we need to arrow out of the square root to close our parentheses. And then we can press divide by 2. So our first approximate answer is going to be negative 2.1. Or, excuse me, negative 0.21. The other approximate answer, I'm going to enter just like I did before, open the parentheses, negative 5, but this time we want to subtract the square root of 21. Again, arrow to the right using these arrow buttons to close the parentheses and then divide by 2. And then press enter, and we have approximately negative 4.79. So this is one problem that has been solved, and this had a leading coefficient of 1. Let's go ahead and take a look at one where the leading coefficient is something other than 1. Here we have that the a value is 2, the b value is 8, and the c value is 5. So using my formula, I'm going to be working with the opposite of b, so the opposite of 8 is negative 8, plus or minus the square root of 8 squared minus 4 times 2 times 5. A is 2, C is 5. All of that is divided by 2 times A, or 2 times 2. So just as we did before, using our order of operations and simplifying our expression, 8 squared is 64. Negative 4 times 2 is negative 8 times 5 is negative 40. And 2 times 2 is 4. So now we have negative 8 plus or minus the square root of 64 minus 40 is 24. Divide that by 2. Now, something that didn't happen with the last problem that we can do on this problem is we can simplify, write it in simplest radical form, the square root of 24. And when I do that, I keep in mind I'm looking for perfect squares. So I know that 4 is a perfect square. The square root of 4 is 2. So I can write the square root of 24 as 4 times 6. Now 6 is a product of two prime numbers, 2 times 3. So I know this won't simplify any further. But now that I am thinking of it as 24 is being 4 times 6, I can also think of this as being the square root of 4 times the square root of 6. And the square root of 4, as I mentioned earlier, is 2. So we can actually write our equation as -8 plus or minus, and instead of the square root of 24, we can write it as 2 times the square root of 6 over 2. Excuse me, that is not 2. We said that it would be 4. I must have been jumping ahead in my mind. So this denominator should be 4. If you were wondering why it suddenly changed to 2, I was not thinking as I was writing. So I can now write this as -8 over 4 plus or minus 2 square root of 6 over 4, and I can simplify each fraction. -8 divided by 4 is -2 plus or minus 2 over 4 simplifies to 1/2. So we can write this as the square root of 6 over 2, because the 2 goes into 4 2 times. So everything I've written here is an example of exact answer. The most simplified form is where I ended up, at -2 plus or minus square root of 6 over 2. If we want the approximate answer, I would just go ahead and use what I initially had in my exact form in my calculator. So opening the calculator again, and clear the first one, so we have open parentheses -8 plus the square root of 24, arrow out, close the parentheses, and divide by 4, not 5. So one approximate answer is -0.78. Or we have to do that again, but this time with a subtract square root of 24. Open the parentheses, -8, subtract the square root 24, arrow out of the square root to close the parentheses, divide by 4. And our other approximate answer is -3.22. And this concludes the video on using the quadratic formula to solve.